your router is not just the box that makes the Wi-Fi happen. I have a feeling if you're watching this on the Linux channel, you probably already know that. It's the edge of your network. It's the thing that every phone, laptop, console, camera, tablet, thermostat, mystery IoT device in your house trusts and uses and connects to the internet via. And if someone compromises it, it can become a beachhead inside your network. That matters more now than it used to, because we're moving to a world where more services are trying to decide who you are, and how old you are, and where you are, and whether your session looks risky, or whether your connection should be trusted in the first place. Banks already care about risk signals. Platforms themselves are moving towards stronger age checks because of, government overreach, government mandates. And now Roblox, for example, probably requires more facial or ID checks to access than you need for your bank account. Like, you can access your bank account with less effort than Roblox. And legislatures are piling all sorts of age verification and no VPNs. Like, oh, let's save the children. So, if you're a criminal, maintaining a presence on someone's real residential network suddenly is a lot more valuable than it was previously. It's not just about the bandwidth. It's about reputation. It's about location. It's about having a way to make malicious activity look like it came from a normal household. It starts with your router. And that's why I think the U.S. government, well-meaning as they might be, are treating this as a national security issue now. The FCC added foreign-produced routers, consumer routers, to the covered list, citing unacceptable national security and cybersecurity risks. And that is the router ban story that you may have heard about, that we've done some content on the security aspects of that, and that's why we've added that for our router reviews. Like, we can actually do security audits. Now, if you didn't catch our main Wi-Fi 7 video, that's a good background for this one. You should probably check that out, because a lot of the things that we said there will make sense here, because this is going to give you some more technical background and technical info. In that video, we started with a simple question. Which Wi-Fi 7 router is the best? As we have done since 802.11n. And then it became Wi-Fi is not Wi-Fi. Well, there's Y and then Fi, and then Wi-Fi 7, and Wi-Fi 7 certified. This is not the box you're looking for, Wi-Fi. This is not the box you're looking for. This is not the Wi-Fi 7 certification you're looking for. That turned into RF chambers and foil-lined rooms and 6 gigahertz weirdness and MLO weirdness, and MLO not really being supported on most things, client support weirdness, firmware weirdness, and eventually even security weirdness. Our tests have run into the same basic consumer problem too. Wi-Fi 7 branding and certification and the language and the actual MLO behavior, multi-link operation, do not always mean what normal people think they mean. And you may not even have those features. Some of them are optional. My individual router reviews are going to give you the performance and security details for each box, and you can catch up on those for your information through our forum and everything else. We got a really, popular user forum. It's a great way to get read in really quickly. But this video is a little different. This is kind of a stop and take a breath video that I just really wanted to do to share how we're doing some of this. This is how Sean and I tested all of this. I turned a pile of Linux scripts, IW output, iperf runs, ping logs, firmware notes, and result folders, and some basic Python graphing scripts into a repeatable, really awesome AI-assisted workflow. And using this kind of feels like the future of what AI could be if AI is actually useful. I think it will be. This is one of the things that makes me excited. The harness for the AI is kind of like magic. We use Turnstone. That's our local agent AI harness with inferencing running locally. No cloud tokens, no pasting router evidence into somebody else's chatbot to try to help with the boring parts. We run the test, we wait, we verify the file exists, we compare it to the previous run, we have the AI look at it maybe and flag a weird result, or to help automate some of that, and we improve the parser that's doing stuff in a script in a deterministic way. This is not AI benchmarks the routers. This is local agents inside a guardrailed process, helping two humans move faster through tedious, repetitive, awful work, but in an auditable way that you can go back and look at it and sort of trust the chart. Turnstone itself is built around tool using agents, work streams, local OpenAI compatible endpoints, tool policies, audit logs, and validation around tool calls, which is exactly the difference between The model said it did some stuff, a la OpenClaw, and process produced evidence. So today is not really a router review. Today is a case study of how we use Linux mostly, and the real star of the show, local inference running on Quadradion? Yes, Quadradion. A machine with 128 gigs of VRAM running scripts and testing. It's the brains behind the harness agent workflow, and it makes things less terrible for us. It's one of the things that is exciting to me about why that this kind of agent workflow stuff might be the future of AI, at least AI that's actually useful and running in a quasi-deterministic kind of a way. Before I show Turnstone, I want to explain the problem it was solving a little better, because this is where a lot of AI demos go wrong. The problem wasn't really so much that Sean and I needed a model to understand Wi-Fi or to do that kind of thing. The problem was that testing Wi-Fi 7 honestly produces a stupid amount of boring data. Every router sort of behaves differently, and every router has its own quirks. Every test needs logs. Every log has little bits of special flavor because of the minor differences in the access points and how the hardware is implemented. Even the different Wi-Fi 7 clients behave a little differently. Every weird result means you got to do a rerun, and things have to be labeled. And that's so future me doesn't accuse past me of doing crimes against spreadsheets. Where do the tests run? Mini PCs, like this one. This is an MSI QBNUC AI Plus. It's Panther Lake. It's a mini PC. This one has a MediaTek MT7925 in it, and it runs Windows, not Linux. But we can use an MCP harness to let Turnstone marionette this thing, and even though it's Windows, we can still test Windows as a Wi-Fi client, which is pretty awesome. Now, our other mini PC is a Minis Forum with a BE201 from Intel. That's pretty much the best all-rounder Wi-Fi 7 card right now. And this is the kind of thing where automation helps, but only if it is boring and inspectable. A lot of these tools are not new. Some of them are old enough to vote. Some of them are written in Bash. Some of them are written in Perl. Some are written in Python. Some of them were written in Python 2, and for this I ported them to Python 3 like late last year. But they do one useful thing. They make the work explicit. This matters a little bit because the agent is not being asked to invent the test. It is being asked to use a tool whose behavior is defined. These are the guardrails. This is agentic use case in its simplest, purest form. So this is where Turnstone comes in. Turnstone is not the benchmark. Turnstone is the orchestration layer around the benchmark. It gives the agent access to the tools, but with permissions, logs, work streams, and auditability. I can see what it ran. I can see what files it touched. I can see what output the tools produced. And if it does something dumb, well, that dumbness is at least preserved in amber for future prosecution. Turnstone gives the agent access to the tools, but with permissions, logs, workstream auditability, and I can see what it ran. I can see what files it touched. I can see what output was produced as a result of running those tools. This is our Turnstone interface. It's a web GUI. You can pipex install this as well. It's got tool calling, output artifact. There's an audit log, a permission system, and this is heuristic based. There's also a shell tool for invoking scripts, skills as you'd expect them. This is the difference between the model said it tested something and, well, let's call that vibes. And here's the command, here's the output, here's the artifact from that command. Here's a normal run. The agent is not allowed to say, oh, this looks good, or I ran this. It has to check whether the files exist. It has to check whether the parser found the expected fields. It has to compare the result against the last known good run. The orchestrator is managing one or more agents that are running on individual nodes. And if the answer is the file is missing, then we can kick off another agent to investigate what's going on there and report back, or if it's a minor problem, take care of it. This is cool. This is also lets me apply the Unix philosophy to my scripts. I've attempted to string together a bunch of my scripts that are simple and sort of razor sharp for the specific thing that they're trying to test. That's sort of the Unix philosophy. And it's easier to maintain because I can keep that laser focus in that one file and keep it sharp. But I can also reasonably expect a harness to run the tests without having to build something that handles a billion weird edge cases. The model can look at it and say, oh, we forgot to install IW. I can ask for permission to install the wireless utilities. Just basic stuff. I mean, okay, that's not a good example because you can script that too, but you know what I mean. It's also been pretty awesome to be able to run this at a fixed cost with, this hardware. Oh yeah, the router ban. Yeah, so The router band also factors in here. It's the same pattern. The same pattern that we're using here for testing also helps on the security side too, because guess what? I got a lot of security scripts as well. And it's not, hey agent, go hack the router. Absolutely not. This is how you get a confident idiot with a shell doing bad things. It's not good. The useful version is much more pedestrian. Inventory services. Compare firmware artifacts. Check for old components. Make sure the same checks run across devices. Download the GPL firmware file because you got to comply with the GPL on these. And look at the versions from the firmware. You don't even have to do anything to the router. Or let me know something changed in the output when we, twiddle with the SMB service, or we check to see that a patch was properly applied. This is all the most boring, pedestrian, basic, low-level stuff. You don't need a Frontier model to do any of this. It is fantastic to be able to run this locally. You don't even really need 4 GPUs. A lot of this I was doing on 2 GPUs, albeit slower and with less parallel. It was less summon the cyber wizard and more, let's appoint a very literal-minded clerk to the department of did we actually run the thing and get an output. So, not a wizard, a clerk. A slightly haunted clerk with grep, but a clerk nonetheless. This is not magic. This is bureaucracy via GPU. And because Turnstone keeps the audit trail, I do not have to trust the summary. I don't have to trust what it's telling me. I can go inspect the commands. I can go inspect the outputs. I can go inspect the artifacts. The agent can be wrong, but it has to be wrong in public. It has to be wrong in such a way that I can prosecute it. And on our user forum, you can see a sample of one of our audits for the netgear. There's almost surely a dark regulatory capture lobbying component of this from netgear. You really should check out the Gamers Nexus video on this. Steve did an excellent job laying that out. Regulatory capture in my router, not actually being interested in security. Yeah, for all the netgear posturing about TP-Link having weak security vibes, well, our audit report in Turnstone is where those vibes have gone to cross-examination. And it does not look good for either one of them, frankly. Certainly, for netgear, I don't think it's a good look for, for them to have a secret service that enables SSH if you send it a magic packet on UDP port 22. That sounds like a literal and figurative backdoor of exactly the sort that the State Department was worried about and they would be interested in. And weirdly, the GPL firmware archives have all disappeared from Netgear's website because they've come under scrutiny with this router ban. So I think we're just getting started on this. Thanks to the community, Level 1 Tech's community, and engagement like yours for supporting crazy projects like this. And please, do engage with us and the community and everything else at large. And check out our other video content on Wi-Fi 7 routers and how we went down this sort of Wi-Fi 7 umbrella rabbit hole kind of thing. We've been doing DIY routers for a long time. Forbidden routers, that's where you run a router as a virtual machine. It's forbidden because it's more troubleshooting steps, but it's really cool for auditability and some other stuff. There's a lot of content for you to discover if you're new here. We've been doing DIY and build it yourself around routers for a really long time, but for 2026, I thought a reboot was in order. And it's taken me a while to do this initial testing. And I had no idea Wi-Fi 7 was such a dumpster fire. And then the router ban happened, and it's like, oh, security. And it's like, aren't these just kind of like treated like disposable appliances anyway? And it turns out the answer is yes, they're still treated like disposable appliances. These companies are not taking them seriously for that. They're being treated like disposable stuff. So I want to call that out. And this is all possible thanks to viewers like you. So thank you. I'm Whittles, Level 1. I'm signing out. You can find me in the Level 1 Text forums, and woohoo, go local agents.